Okay, I think we can get started. So good morning still, everyone, and welcome to the Sustainable Places workshop called Life Cycle Sustainability Assessment, the environmental and social applications of LCA in the built environment. So really focusing on buildings, on environmental impacts, and probably also social impacts. Some of the projects will touch on this. We've got 5 projects. We'll be listening to the presentations of IMMEC, Efficiency and Environmental Impacts of Building Material Cycles, followed by CIRCUSTAIN, Impact Assessment of Circular Economy Initiatives in Construction. Actually, I think I've got a slide for that there. So the first one will be Thomas Gibon from LIST presenting. Also, I should introduce myself. I'm very sorry about that. My name is Kalin Boje from LIST as well. And then we have CIRCUSTAIN, yes, by Nirvana Martin. The Miracle Project after that with Nick Adams from KU Leuven. Then REGEN Project is the one that I will be presenting. It's around the regeneration of neighborhoods. And then ASIRE or ASIRE Project, LCA to reduce the energy poverty and environmental impacts of residential building stock by ELS later. So I think that we will try to fit in a 10-minute presentation for each project, and we're going to give it 1 or 2 questions at the end of each presentation, so you have some time to digest the content of each project. And then towards the end of the session, we will open the floor to everyone, concerns, and we'll try to see the common trends or the common challenges that the projects are facing, and maybe see how this might be going forward. And without further ado, I want to invite Thomas Gibon with the first presentation.
Thank you. Thank you, Kalin, for the introduction. Hi, everyone. Very happy to be here to present some outcomes of our project IMMEC, Integrated Modeling of Material Efficiency and Environmental Impact of Building Cycles. It's a long title. This is a partnership between LIST and University of Kassel, and it's been founded by both the research agencies of Luxembourg and Germany. I guess I have to use this. So this project is born from basically 3 main challenges that we are facing at the moment. The first fact is that future climate change impacts of the plastics industry can be reduced by enhanced recycling. So circularity is actually clearly a big part of climate change impact reduction, so greenhouse gas emission reduction for plastics. At the same time, the presence of legacy contaminants, and namely, as we will see, lead, for example, in PVC products, is a significant barrier for more effective recycling. The problem is that if you want to recycle and actually adhere to the current legislation, you cannot use some of the old material, because this old material actually contains what we call substances of I forgot what it's called, but legacy contaminants, and actually that's an issue because you cannot just reintroduce them like that. And so products in the building and infrastructure sector are also here over a long period of time. So this legacy contaminant is not really an issue for, let's say, packaging, because the packaging is being made and recycled maybe over the same year. But for building products, typically 40 years for a window frame, or for PVC flooring, it will be like maybe 10 years. We will have these problems of maybe reintroducing some contaminants that are now under a regulation. So what do you do? What we have done is to analyze this trade-off between toxicity impacts, climate change impacts, restriction of, in this case, in the case study I will show, of lead in PVC, and as well recycling rate. And we will show that you cannot be good on all aspects. So basically you will have to choose between one or the other. And where you put the slider for the threshold of lead that you would reintroduce is actually quite important. So what we did was to build this input-driven dynamic material flow and stock model. This is for Germany, and this is for all the buildings, so the building stock of Germany, between 1960 and 2120, so in 100 years from now. We have to use these long time ranges to account for production, construction, and decommissioning, destruction of buildings. And we focus on PVC materials, and especially window frames. PVC products, and window frames. This is input-driven, so you actually drive your model according to how many window frames you will need over a year. This changes, of course, year on year, and we have prospective scenarios to simulate growth in demand, or stagnation in demand, or even lower demand. And of course, not all window frames arrive at their end of life at the same time, so you also have to account for distributions to represent their lifetimes. And so this model actually tells you what would the flows of PVC coming into end of life would look like under different assumptions, including the assumption, the main one being that we would like to restrict the amount of lead going out into this flow in 2034 in Europe. And right now, the level of lead is still way too high compared to what is planned to implement. So what is going to happen then is the big question. Of course, right now we recycle a lot of PVC. It's good for the material efficiency. It's also good for climate because you also avoid the production of virgin plastics. So you actually have a lot of avoided greenhouse gas emissions due to that. What we've done is then to have this, I don't know if I have a little pointer, maybe not. We have built this dynamic material flow analysis model that you've just seen. We plug to that an LCA layer, life cycle assessment layer, to calculate the impacts of each production stage, or in this case, recycling or incineration stage as well, to account for impacts, and that's not calculated according to what the economy is today. We also use this prospective impact assessment model to assume that, for example, any process using electricity in 2050 will use the electricity of 2050. And so we make this scenario analysis where we put the restriction on or not, different technology scenario for the incineration, because all the excess of PVC that won't be recycled anymore can go to either normal incineration with CCS, etc., also with HCl recovery, and some detection scenarios that will make it possible to optimize the end-of-life flow to orient only the flows that are actually high lead and keep the rest to recycling or not, or to use an average. So all this, and then we try to analyze this trade-off between those three aspects, life cycle impacts, recycling rate, and PVC profile in use stocks. So this is how the market looks like. The red part is the bad, I see there's no legend, but it's the part that's actually not eligible to recycling anymore. Orange is not recycled, but I think it's between 0.1 and 0.5%, and the green will be under 0.5% of lead, and that will be eligible to recycling. If you don't have any restriction and you keep the restriction as it is today, of course you have much more that's eligible to recycling in the future, so it's better for circularity and for climate, but of course you will reintroduce lead in PVC. What happens in terms of environmental impacts? Between now and 2100, right now it's actually a net negative if you don't have any restriction, because any PVC you produce from recycled material avoids the production of virgin PVC, so most of it most of this negative impact is due to the substitution of PVC in green. If you start having this restriction, you can't do this anymore, basically, so you have to choose municipal solid waste incineration. That's the dark reddish part that you see on the positive aspect of the graph, positive zone of the graph, and that actually puts your net emissions on the positive side. And you start emitting carbon where before you were actually avoiding carbon. And that's true for all kinds of restrictions and with different incineration scenarios. It's actually quite important because even if you recover carbon, recover HCl, it's not enough in terms of substituted material to avoid emissions, at least on the net level. So if you compare these three dimensions, first the lead in PVC, of course the no restriction scenario will keep lead quite high, that's the top graph, and the restriction will actually decrease your amount of lead in PVC. That's what we want to do. It shows here that your restriction will actually happen over a very long time. Even if you put the restriction in 2034, you will still have lead in PVC until pretty much the end of the century due to the long-lived nature of buildings. This is the amount of recycled PVC you can get, and you can only get back to the actual levels of recycling about the end of the century as well in the restriction scenario. It's actually quite impressive. Everything else will have to be incinerated. And the last one is what type of impact that provides. So if you do the accounting of greenhouse gases with this substitution method, then you can see that clearly you have much lower emissions right now in the no restriction scenario than if you apply restriction. There's some scenarios, but in a sense, the conclusion is the same. So if you try to plot this on different levels, where the idea would be in this triangle to cover most of the area of the triangle, you see that no one scenario, restriction or not, is able to do this. You will always have to leave one of the indicators behind, or two behind, to actually gain more on the last one or the two others. And the issue here is clearly that if you want to reduce lead in your PVC product, you will have to trade off with greenhouse gas avoided and with recycling rates. So some key messages. The window flows, they're expected to increase by a factor of 1.7 between now and 2050. So we can't really deal with the demand either. It's actually, this PVC window frame case study is actually a case where you don't really have an option of reducing the demand. And lead will be present basically for at least 3 more decades at 0.5%. This restriction will limit future mechanical recycling. That's clearly an issue because everything, all the flows, even if you can manage to sort out the ones that are still eligible and the ones that are above the threshold, you won't be able to reduce your excess material, or you won't be, said otherwise, you won't be able to recycle as much as before. And that really poses a problem as to what to do with the rest, incineration. Incineration for the most part. There are some chemical recycling options for PVC, but we didn't account for that because it's really an emerging technology, and it's not something we have data for. And so the environmental impact for the different management scenarios, they were assessed also under different background conditions. So some of these processes, for example, use a lot of electricity. These processes will have a lower impact in a scenario that's compliant with 2 degrees and will have a higher impact with the scenario that's not compliant with 2 degrees. So we also account for everything changing in the background economy in terms of technical aspects. And the assessment showed that the alternative treatment pathways can mitigate the effect of excess PVC mechanical recycling. But the conclusion is that there's no perfect answer to our dealing with the trade-off between the 3 aspects of decontamination, environmental impacts, and recycling. And I believe my time is over. Thank you.
Take some time for 1 or 2 questions quickly before we move on to the next one.
Yeah, this works. Yeah.
Oh, I got that one.
Sorry. Thank you. My name is Inge-Lise Svensson. I'm from RISE in Sweden. And I'm not very familiar with window frames of PVC, so this might be a stupid question, but at what stage is the lead causing the most problems? Is it when it's in place, or is it when recycled, or when it's incinerated?
Yeah. Actually, the lead is, for the most part, inert when it's in the PVC. It's used as a stabilizer, actually, for the product, for the material. Right. So it's not really an issue during the use phase, as long as you don't go and grind your window frames, and that's not really a problem. But it becomes a problem in the end-of-life flow. What happens to it afterwards? Right. When it's being processed, mechanically recycled, that becomes an issue, and emissions can occur then.
Okay, so then prolonging the life of the windows as well might also be a solution.
It is, yes. Actually, we have a little sub-scenario with this, which shows that it's actually a solution. It kind of postpones the problem, though, because we still want to reduce lead levels, but that's one of the solutions, yes.
Thank you.
Okay. Oh.
I don't know if it's a question or more a comment, because as you showed at the end, PVC is not that good. In some countries also, it's a material that is being studied. It's a red list of many products. It's not a health product. And also, so there is this environmental aspect. So if you go to recycle, and if you try to make it safe, like you reduce the use of lead, so you decrease your recycled Like you will have more downcycling than upcycling or get back into the system. And so what would be the advantage? Only economic?
Yeah, it's a very good question.
So sorry.
Yeah, the main reason we use plastics and PVC in particular, and you're right to point out that it's one of the worst polymers. It's very difficult to recycle. It has all these additives. It's mainly for costs. I think there's also some aesthetic aspect, some longevity. I mean, a lot of products are made in. I mean, what are the alternatives apart from wood, aluminium maybe, and some, I don't even know if some other polymers can be used. But it's usually for heavy-duty stuff. For flooring, for example, PVC is used a lot, and that causes issue because recycling this PVC flooring is complicated. I don't really have a clear answer. And thanks for your comment, but I think it's just an economic aspect in the first place. Yeah.
Okay, thanks for the questions. We're coming up with CIRCUSTAIN and Nirvana. That's yours.
Okay, so I will talk about the project CIRCUSTAIN. My name is Nirvana Martin, and I work for the Luxembourg Institute of Science and Technology. So CIRCUSTAIN has a long title, as you can see, Advancing and Conducting the Impact Assessment of Circular Economy Initiatives on all three sustainability pillars through integrated life cycle sustainability assessment with a focus on PVC in the construction sector. So, it was estimated in 2022 that in the European Union, 2.4 million tons of post-consumer PVC waste was generated, and 44% of these were generated in the construction sector. This puts the construction sector as an important player in the circular economy. So, as we saw before, PVC in the construction sector is used for piping, flooring, profiles, and others. And there are post-consumer collection schemes and also mechanical recycling in place, but however, circular economy practices are not sustainable per se. And for this reason, we need life cycle sustainability assessment to understand the sustainability of such systems. So what is the aim of the project CIRCUSTAIN? The main two key advancements of the project are, first, it will include the social dimension of sustainability. So we aim to assess also this pillar, tackling, for example, job creation. And the second key advancement is that it tries to explore cost-effect chains between the different dimensions of sustainability, so environmental with economical and social. So what is the state of the art of these methodologies? As you might know, environmental life cycle assessment is a key methodology to assess sustainability. And taking this as a basis, other methodologies were created. These are the social life cycle assessment and the life cycle costing. So that is what we call the life cycle sustainability assessment. It covers all of these three methodologies. And currently, they can be performed separately, and then a score can be calculated for each of them and then somehow combined. But in CIRCUSTAIN, what we aim to do is to integrate the three pillars through cause-effect chains. And I will go back to this point later. So the research question of the project is, what is the sustainability impact of circular economy initiatives focusing on PVC in the construction sector when considering social labor-related impacts integrated with the other dimensions? The first objective is to quantify the social issues and job creation. The second is to model two cause-effect chains affected by circular economy initiatives. And the third one is to apply this advanced LCA SA framework with a two cause-effect chains model. So here you can see an example of this mapping. So this is an exemplary mapping that was performed for the project. In green, you can see the environmental aspects, in orange, the social, and in blue, the economic ones. And as an example, we have the initiative here, the recycling of the PVC in yellow. And this initiative could somehow lower the local pollutant emissions over the product system, which could be positive for the environment. And this could imply less negative impact on the health. And there you see the population health and well-being, which could, in turn, be positive for the labor force availability, who would, again, work for the circular economy initiatives. So the idea, in the first place, is to map qualitatively these different cause-effect chains, and then to model two in a quantitative form. And this is something that has been rarely explored in life cycle sustainability assessment. So to connect the different dimensions by finding cause-effect chains. So we expect that the impact of these results would be positive for society in guiding decision-making and inducing reflections on circular economy. For the industry, providing feedback to the sectors involved, and for the scientific community, it would mean an advancement in the field of sustainability. So as you have seen, this project is in the first year, so it started this year, in 2024, and it will last until 2027. We are currently in the working package 1. And in this working package, what we are doing is trying to estimate the amount of work hours that are corresponding to each of the stages, comparing a linear and a circular scenario. And with these working hours, we can estimate the amount of job creation and then compare the amount of job creation in each of these scenarios. And for example, we know that mechanical recycling, sorting, collection, and other activities also in the construction sector, where this installation take more time of people than in the conventional PVC production, which is highly automatized. This is the working package 1, and then, as said before, the working package 2 will try to assess these cause-effect chains. In the working package 3, we will integrate these cause-effect chains into conventional life cycle sustainability assessment. Thank you, and this project has been funded wholly by the Fonds National de la Recherche, and those are the contacts for me and my colleague who is the principal investigator, Thomas. Yes, thank you. And one thing to add, I will be giving a presentation tomorrow on what we're doing specifically in working package 1 about those work hours and job creation estimation. Yes, it will be more detailed than this one, this presentation.
Thank you very much, Nirvana. So I think this is the first flavor into the social side of LCA, let's say. Any questions before we move on to the next one? If not, you have time at the end to ask questions to all the projects. We've got opening questions at the end. Okay, so I'm up next, I think. Or Nick, is it? Can we see the next slides? Sorry. It might be you, yes. It's Nick, okay, you go. Sorry.
Okay, so hello everyone, my name is Nick Adams. I'm from KU Leuven. And I'm working in my PhD on the Horizon 2020 project Miracle, and I will talk about how we integrate LCA into the Horizon 2020 project that is going on. So first, I want to say what is it about. So radiative cooling materials already exist, and these are kind of materials that are placed on top of buildings and have very high reflectivity to reflect incoming solar irradiation, and they have also a very specific emissivity which can dump heat into outer space instead of being captured in the atmosphere. So these materials then can be placed on top of buildings and cities, and they can help to mitigate urban heat islands, and they can help to mitigate the energy use for cooling in summer as well. And these materials, they already exist, but they are made with very toxic materials, very heavy metals, very energy-consuming production processes, and so on. So we try to do better in this project. So here with this project Miracle, we are trying to make one of these materials, but based on conventional concrete, because we know how concrete works, we know the impact of concrete, and we can make very big scales instead of like these very small materials. So that's what we want to do with Miracle. So the project is divided in 6 work packages, where the first work package, they look into what are the components of the concrete. The second one, they look into how do we actually make this concrete. The third one is when they add the reflectivity and emissivity that they want to the concrete. The fourth one is when they make the first prototype, they put it on a building and they test what can it do on internal temperature and energy use. And then we are doing the fifth one, which is we look into the impact of this concrete, so both the negative impact, so we do an LCA study, and also the positive impact on the urban heat islands and the cooling demands, and then we can see if we can put this all together. So we go back to work package 1, 2, and 3, and then we do a cradle-to-gate environmental impact assessment of the components and mixtures of the Miracle that they want and they want us to investigate. And we also do this of existing cooling materials because we want to compare to something and see how good or bad is our material doing. And then also we go back to work package 4, where we do an LCA of the prototype, and then we also look into the LCA, the full assessment, so also the production phase, construction phase. And the most important one for us is the use phase, because we want to know what about this energy reduction and this urban heat islands reduction, and we want to take this into our LCA. So now I go very quick over the 4 parts we are doing, and I will show some first results we have. So the first part is the environmental impact of the Miracle concrete, the first mixture, and also of the existing cooling materials. So here, for example, they gave us the first composition, which is Portland cement, aggregates, steel microfibers, and so on. And here we see everything by mass percentages. And then we did a first LCA analysis and all different impact categories. And then, for example, we saw that the steel microfibers have a very high environmental impact. So we said, okay, let's try to use something else or reduce the amount of this. That was the first step. And then we also looked into how can we now, so this first bar is the environmental impact of the first composition, and then we look into how can we now reduce this impact by changing things in the composition or doing other things. So for example, the fourth bar, where you see the reduction, that's when we use recycled steel instead of virgin steel for making the microfibers. And the last bar, for example, is what if we reduce the thickness of the material and also only have steel fibers on top instead of in the whole material. And then we see that, for example, we have an environmental impact reduction of 78%, which is quite significant. So that was the first mixture. And then also we want to compare it to the existing cooling materials, because if you have an environmental impact, you need to compare to materials that do the same thing, because otherwise, what do you compare and how are you doing this? And there wasn't a LCA assessment of existing cooling materials, so we said, okay, let's take our time then now to develop something, a framework to assess these cooling materials and also take into account their cooling potential or their performance, because we think we need to look at both together. So what we did here, for example, is the framework consists of 4 parts, where the first part is just we select the cooling materials. And now, for example, we selected 10 materials that we found, so where we have enough information about. Then we assessed their environmental impact, so we set up a system boundary that we thought is important now. And we calculated of these 10 materials, for example, their environmental impact, where we saw that some materials have a very high impact, the second and the third one, because of the high energy use of production, where some others, for the 6 and the 7 one, have a very low impact because they don't have these production processes, for example. Then we also developed a methodology to assess the cooling potential of the cooling performance of all these materials based on the same way, so we can compare the performance of all these materials. And then to end, we put them all together with the single score environmental impacts on the x-axis and their cooling performance on the y-axis to now see, okay, if we take these two into account, if we take these two into account, which material scores best based on both parameters. And now what we now will do, because this is finished now we will do the exact same thing for the new miracle compositions or the prototype, and then we can compare them in the same way to all the existing materials. Another part we're also looking into is the effects of the cooling potential on buildings. So therefore we use Energy Plus, which is an energy building simulation software. And here we want to see, so we have a test building, and for example, we have one simulation when there's no thermal insulation inside, and we have just normal outside materials. And then we also do one simulation when on the outer surface of the building we add this new material, our new Photonic Meta-Concrete, and we see what is the difference by implementing this material on the indoor temperature and also on the energy use for cooling and for heating. And then we also did the same, but with thermal insulation. Then we can compare, is this material best to put on a building without insulation? Is it best to put on a building with insulation? And what is the effect of this? And we just started doing this, so I don't have any results now. But we saw, for example, that implementing this material on an already insulated building doesn't do a lot, because then the cooling performance of the material is blocked by the insulation, for example. Then the third part is the urban heat island mitigation, where we use climate models. So it's like a model where you, for example, divide your globe or your domain you want into boxes, and then it calculates all the physical properties between these boxes. And here we said, okay, for example, what if we implement this cooling material on top of every building in urban areas, and what does it do with the urban temperature or the urban heat island? And here, for example, on the figures on the right-hand side, you see during a heat wave, you see the average temperature reduction during the evening or when the urban heat island occurs. And there you see clearly that all the urban areas cool down by implementing this material with a very high reflectivity and emissivity. So now we also want to see, okay, this amount of temperature reduction, how can we also put this into kilograms CO2 equivalent, for example? Then we can also take this into account in our LCA. And finally, we also look into the effect on climate change overall. And then we do it radiative forcing, which is a very physical thing that I will not explain completely, but we just look into what if we implement this material, what is the netto additional radiation that we will put on the top of the atmosphere to outer space, and this amount can be translated into kilograms CO2 equivalent as well. So then we can also take this into account on a bigger scale into our LCA. So here's what I said. So now we want to combine all these four topics that I just said. So the environmental impact of the material, the cooling performance, so the reduction of energy use. We also want to take this urban heat island reduction into account and this climate change into account, and express this all in kilograms CO2 equivalents, and then put it all together to one big LCA that we can also that we can take into account everything of this material, the positive and the bad aspects. So then I want to end with the slide I had in the beginning, because within the project, for example, we all knew we had work packages, and I knew what I had to do for the LCA part. But for example, the LCA of the existing cooling materials wasn't in the proposal at all, but we just found out by doing it that this was something that had to be done. So I think almost half our time was spent on this, which was something we didn't expect, but was necessary to do to complete the project. And also, the project will be finished by the end of January, so I hope then that we can put this all together. Thank you.
Thank you, Nick. Very impressive. Questions? Huh?
Thanks for the presentation. I have a very simple question, I think. So you're converting back this radiative forcing back into kilogram CO2 equivalents to get the final score.
Yeah.
How do you do that?
Yeah, that's something that we're still looking into now. So almost everything I said, so the 4 parts that we're doing, we are finishing them all up. Yeah. Also the energy simulations, we're now looking into the results and finishing it up. And then now we still have 3 months, I think, where we want to really look into how can we now put this all into kilograms CO2 equivalents. Because we also don't know information about it, because this material is very new, so we don't know how long will it last, what is lifespan, how many times does it need to be replaced. So I think we will have some scenarios and see what the outcome can be.
Yeah. Very interesting. Thanks.
Good morning, Huub Keijzer from TNO. I actually have a question. Is it also applicable for renovation purposes, so as an add-on? And do you also envisage to investigate that?
Yeah, so so it's a very good question, because also we are all looking into that, because as I said, we put it in the energy simulations now on insulated and uninsulated buildings, and we saw on an already insulated building it doesn't do anything. So we were thinking it could be a good renovation for uninsulated buildings in cities who like these very old buildings or pitched roofs, and then it can be just renovation instead of. Then you can see, is it better to put insulation in my building, or is it better to just apply this material on top of the building? But you're still looking into what will the actual application be, because the material only needs to be like 100 nanometers thick. But you're saying, yeah, then it will also be, the production process will be very intense, because if you want a very thin material. So now I think they are looking into making it roofed the tiles, where the bottom of the tile will just be conventional concrete, and then on top they will pour like a very thin layer of this material. So that's what they're looking into now, but we still don't know the final application. But we are looking into this. And we also have an additional project which will start when Miracle stops. So it's how do you say it? Also on Horizon is a booster, where we look into, then we will see, can we apply this material on which kind of building, in which kind of climate, and so we really want to see what is the potential in every climate, on every building, on every situation, to see if it can be applied. Yeah.
Okay. I think we're good.
Thank you.
Thank you, Nick. And I think I'm up next, this time for real. Okay. So, hi everyone. So my name is Kalin Borge, once again. This is about the REGEN project. I haven't really thought about including all the work packages, descriptions, or now I thought that might also be useful. I'll be focusing down on one of the specific tasks of the project, but if you want to find out more about REGEN, we have a booth and a demonstration. So it's one of the projects that started this year in LIST. It's coordinated by LIST. And yeah, we don't have a lot of results. What I want to go through with you today is the impacts of what we call regeneration interventions, specifically out of REGEN. So the premise of REGEN is set around a city district or urban environments, so we scale up a little bit from the building side, which we saw some very interesting presentations earlier. And the whole premise is that these are usually cities with certain problems. Either they want to renovate parts of their buildings or parks or solve certain social problems. So we need to intervene to some degree to make some changes. And so we came up with a sort of a catalog of interventions or of things to do, let's say, or things that you could do to increase the economic well-being and the prosperity of citizens while at the same time, of course, trying to balance the trade-off of costs, environmental impacts, and social gains. And so here's a quick overview of some of the interventions, what they might look like. They're really just kind of like a wish list at this point, and we're trying to figure out how to quantify them and how to consider them in our pilots. We have 4 pilots. We have a small town here in Luxembourg, in Beccarish. We have the city of Milano around a social housing building. We have the city of Laredo in Spain, and that will be more focused on mobility aspects. And then we have one city district in Dublin that's also about renovating and improving the energy performance of, again, places with social housing and other apartment blocks. So it's really related to mobility, energy, some materials. So all these interventions, some of them might be applied on certain projects or certain pilots, whereas other interventions on other pilots. So it gives us a good mix. And we started looking at this initially from life cycle sustainability assessment. So if you remember from Nirvana's presentation, she was explaining how we're trying to integrate environmental, social, and life cycle costs into a more unified methodology. So this is a life cycle sustainability assessment. So this is also what we try to do. And we have a certain methodology, which we call it AFUR, or Assessment Framework for Urban Regeneration. And we are trying to consider that anything we do, right, has an environmental impact, probably negative. You can avoid it, but what the benefits of this is that we're trying to do this with reasonable costs and with the social gain. So the social impact on the communities needs to be noticeable. The people need to be happier. I mean, that's why we're building houses and renovating and so on, so that people feel that they have an environment that they can feel comfortable with. And so on this one, this is what we're trying to focus on, what are the positive impacts, usually from the social side. So this is where it becomes very difficult, I think, for us to try to frame it and to quantify it. And then we will also look, of course, at the more conventional environmental life cycle assessment to try to calculate the impacts of the interventions. So an intervention is kind of like, I'm going to do this to renovate my town or to regenerate my town. I can, to some degree, because LCA is quite well established, estimate, the amounts of materials I'm putting into this and how I can calculate the carbon out of that. But I'm uncertain as to what the social benefit on the society that I'm acting upon will be. And so this is one of the key challenges in REGEN. So this is part of task 2.5 in Work Package 2 and the development of the framework itself. So I just want to go through the key stages of the framework. So we have an initial, we've split this into 5 phases throughout the project. So it's sort of the core methodology of the REGEN project. So we have an initial estimation. We're going through this right now. So we're looking at each pilot site and we're asking them what they want to do from the list of interventions. And they're saying, I want to do this, I want to do that, and this way, and so on. So we're trying to estimate what it is that they have, okay? And this is kind of the baseline. So I'm looking at the city of Milano, for example, and I'm seeing that this is the current state, or, for example, the baseline of the energy performance of the buildings. They're performing in this way. And then we're implementing some monitoring techniques, if possible and if necessary. So, for example, the mobility case of Laredo will be monitoring how people are moving through the city with the occupancy sensors. And then in the third phase, which is what it's more related to this methodology, is trying to evaluate whether I should implement this set of interventions or the other set of interventions together and see what the outcomes might be. So like I said, doing the environmental impact assessment might be relatively straightforward, but doing the social ones might be difficult. Then, of course, at the end, we have a benchmarking, trying to understand whether it was a good option or whether this is the good option to take or not. And then moving again a bit on the social side. So this is not really within the context of REGEN, but this is something that we published last year as part of another project, looking at the building and looking at how we might be able to estimate the social side of things. So it's very similar to what we saw previously, where you guys were doing the phases of the building. We've only focused on certain ones: the production of materials, the energy consumption from monitoring data, that we then try to simulate for the future. And then some water consumption, but it's completely irrelevant. Looking at the results, the water consumption was very low. So you can have a look at the paper. It's open source if you're interested in more details. But I just want to point out that here we managed to some degree at the building level to quantify the social impacts using social life cycle assessments. So this is done by my colleagues, especially Thomas Schobrook. He's actually the lead for a CIRCUSTAIN project that Nirvana presented. So there is a way to looking at the building, the energy consumption, the mapping of all these processes to quantify environmental, the costs obviously, but then also the social impacts using social LCA. And this gives you an equivalent of medium risk hours, which is sort of a unified indicator similar to a CO2 equivalent for the social part. But the problem is that this is global. This is considering the global supply chain of the energy is coming from Germany, and so I don't know what the social benefits are on the local scale. So looking at the REGEN project, if I'm acting upon this local community, even though I'm using sustainable energy and I can calculate it using this social, let's say, methodology, I am uncertain how I would evaluate it locally, although globally you can do it. So for us, I think we settled on the fact that we're not going to do this sort of approach, or at least not yet. We can estimate certain things based on the materials of our interventions, but we're uncertain how we might approach it. So then we took a different approach. We zoomed out a little bit and we looked towards donut economics. So I don't know if any of you or many of you are familiar with this. And we tried to look at the ecological ceiling and social foundations, so trying to meet the social needs while not exceeding the carbon footprint, doing these interventions. And donut, however, is still a little bit high level. We had scoping on smaller districts, and we looked into certain design and green certification schemes such as DGNB, LEED, BREEAM, WELL, Green Pass, and so on. We made a table and we tried to find the indicators, not specifically the ones that are related to environmental or materials, because there's plenty, but trying to see what other indicators might suggest that the city or the local environment is improving. And so far, I think from what we've noticed, I don't have the list of indicators, we're going through them, but here you can see in this diagram more or less the two sides of the balance, the two sides of the scales, where on the top you have everything related to the environment, the consumption of materials or consumption or use of materials, in terms of infrastructure, right? And then at the bottom you have certain things that are more social related, or decent homes, access to decent services, pleasant and safe neighborhoods that are harder to quantify. So this is, we're looking at indicators at the bottom box, let's say, to try to tell us we are implementing these interventions, we're having this much environmental impact, but what are we gaining? What are our citizens gaining in terms of social benefits? So it's still inconclusive, it's still ongoing, but by the end of the year we should have something more concrete, and then we'll go through the pilot, the phase 1 of this diagram, the estimation of the baselines. So I think that's it. So any questions?
Thank you very much for your presentation. I really like the REGEN project. So can you get back to the previous slide? When you have all the indicators and the environment, no, that one.
This one?
Not that one, the next
This
one, this one. So you have analyzed in the environmental impacts, also like the social visual or supply services for inhabitants and visitors. And what about the economic aspects? Did you have this analysis too, or selected some indicators for these two, just to complete like as you use sustainability frameworks?
Yes, so in the costs we haven't dug into it very much, to be honest. because we saw that the problematic might be what are the gains, and that the costs really is also related to the pilots, because the pilots or the demo sites, they might have their own agenda in terms of, we know that we want to do this and it's going to cost us this much, and we're here to tell them, okay, but you're going to emit this much carbon and these are your social benefits. So we're really trying to balance to some degree to try to analyze the trade-off. The problem is that certain interventions are easier to calculate the costs, or while others not. And we also need to consider them together. So the way that we've defined interventions are quite, let's say, singular. So, you know, like installing benches in a park, let's say that's an intervention. But I'm not going to do just that. I'm going to do a bunch of things. And so that's another issue which we don't really know how we will aggregate our inventory, let's say. So that's,
Thank you.
Hello, my name is Esra. I'm from Turkey, and we have been looking into some how to perform social LCA analysis for renovation buildings on social housing in a Horizon project. And I was wondering if you have already identified a methodology to evaluate the social parts, like are you going to use surveys from stakeholders, or?
So yeah, correct. So we are also going to, that's also included in the project as part of a different task. So I try to focus more on things that might be quantifiable, indexes, indicators, life cycle, environmental and social assessment. But there is another task by our Luxembourg partner, LCA, so it's the Social Institute in Luxembourg, and they've already prepared questionnaires. They've got one round of questionnaires that they want to do before certain things are changed. So they're going to go and ask and see what the problems are and try to identify the patterns and behaviors of people in these pilot sites. And then based on that also, we might have to adjust which interventions are more suitable. So you see it's another sort of completely different track. But that's kind of at the last phase of the methodology. So somewhere around the regeneration phase 5 is, and then benchmarking is where we will have to consider the responses of after. So of after the implementation of intervention. So while we can estimate, quantify impacts, still the feedback from the citizens in a questionnaire will tell us again as a different sort of indicator more how this worked or whether it worked or not. So it's always a risk, I assume. So the methodology is a social one, but I really don't know how to explain it because I'm not an expert on that. But there is that part as well.
Yeah. Okay, thank you. I will take a look at it through the webpage then later on. Thank you.
You can see us on the booth and you can maybe give you some indications there. Okay, so we'll move to the final presentation of the workshop. Else? Thank you.
Good morning from my side as well. Work? Where do I have to point? How does that? Okay, you have to be patient. So, good morning again. My name is Els van der Moortel. I work at the architectural department of KU Leuven, colleague of Nick. And the project I would like to talk to you about today is our ASIRE project. It's an acronym for Assessment Method and Selection Instrument to reduce both energy poverty and environmental impact. So, as we all know, we have to reduce the impact of our built environment by 2050. But our outdated and energy inefficient buildings, they do not only cause trouble for our climate and our environment, they also induce energy poverty. So those are the two main problems we would like to tackle in our ASIRE project. We focus on the residential building stock, and it is very important in our project that the solutions that we come up with are financially feasible and affordable for all the parties involved. So how we want to do it is we are looking at integrating bio-based and circular materials in our renovation scenarios. And we're also looking at collective and cooperative economy for the energy provision in the neighborhood. In the ASIRE project, we test our solutions on a social housing stock. As in Belgium, the social housing neighborhoods are quite similar. So that means that the solutions that we come up with are highly replicable. In our project, we use life cycle assessment for multiple purposes. The first one I would like to show is the first part of the project where we use the LCA to assess the environmental impact of bio-based materials. So as you can see on the slide, we focused on more than one indicator, so we did not limit ourselves to only investigate the impact on climate change, but we also looked at the set of 17 environmental indicators to avoid the risk of burden shifting, so to make sure that we do not create a problem elsewhere while we're trying to solve our issue with climate change. In the second part of our project, we'll use LCA to assess the environmental impact of collective heating system. So here we want to investigate what the environmental impact is, not only of the energy that we're using, but also of all the materials that we need for this collective system. The aim of this part of the project is to optimize the grid size, so to find an optimal balance of the number of houses which we can serve with this district heating, and also to find the optimal renovation rate for the houses. So we really want to balance out the energy efficiency of the system with the environmental impact of the whole neighborhood. A third part, we combine the environmental and the financial life cycle assessment. So here we study for a certain building or building type the current situation, for which we define an environmental impact, as you can see on the x-axis, and a financial cost, as you can see on the y-axis. And we do the same for a whole set of renovation scenarios. By doing so, we can actually see the consequences of our renovation. So the part that's indicated in gray shows the renovation options that have both a lower financial cost and a lower environmental impact. But it can also use just to show the client what the effect of his renovation has. For example, if they really want to go to a minimal environmental impact, they need to pay a bit more, and that's what you see in the graphs here. So the ones on top are the ones with the lowest impact but the highest cost. And the final part of the ASIRE project is probably the most leaning towards social LCA, because here we are looking at affordability. So we studied a few economic models on how to make the sustainable renovation of our social housing stock, how to make it possible. And in those economic models, each time we studied the affordability for both the housing association as for the tenants. This is related to some findings from earlier research, where we found that, for example, if you do a very expensive renovation where you have a low energy demand and you try to answer this energy demand with a heat pump, then actually, so you do a huge investment as a social housing company, but at the end, your tenant has to pay more for energy, because in Belgium, the price of electricity is way higher than the price of natural gas. So it's a very high cost, but in the end, your tenant has to pay more to live in his energy efficient house, which is, of course, not the aim of renovation. Oh, sorry. So in our ASIRE project, we work together with 3 research groups, and we received funding from our university to further develop our research into some practical applications. And that's why we're here today, because we're always looking at opportunities to collaborate. For example, we will now start 2 European projects, the Green Renovate project and the Indicate project, where we will focus if I could just summarize it in one sentence on how to renovate large building stocks in a sustainable way. But we also have projects where we do policy support and we collaborate with industries. So I would like to conclude with an invitation to please contact us if you think we can be of any assistance in the project you want to work on in the future. Thank you.
Questions? Thank you, Alice. Going once, going twice. Okay. So I guess we can move on to the open discussion workshop. So if you had any questions from before, for example, or I guess my question to the presenters and well to all of you would be, what is the common line between I think it's very difficult to find a common denominator between these projects, from materials to the effects of labor to regeneration of neighborhoods and the renovation of buildings and houses. That's really, you can see that LCA is everywhere. So any thoughts on that? Or oh, you cannot hear me. Okay, I'm sorry. While you think on that, I had a question for Nick from the last presentation. So you showed us that the energy modeling of the house was done using Energy Plus, and you want to scale up to a district, or at least a heat island of a city or city district, urban area, right? What sort of modeling techniques were you using for? I know it's not LCA related, but I was curious. Yeah, you can use this one.
So actually, that's loud. So for now, actually, we don't want to scale up to like a bigger area or bigger scale. So now we just want to see what does it do with one specific building. So that's where we're going now. So within the Miracle project now, we will just focus on what will it do on one building and just this building we saw, and then we will see an impact on energy use per square meter of building. And then in the booster project, we will look into bigger buildings, other types of buildings, and then we will also maybe look into a bigger scale and a city scale. But for now, we don't plan to look into it for now. But I think it would indeed be very interesting because the goal of the project also is to implement these kind of materials in a big scale in a city. So it would also be evident that we also tackle heating on a bigger scale and do this all together. But I don't have an answer now yet.
How feasible would it be to make everyone in a city district use that one material, though I'm not sure how that's
possible.
Right. Is anyone else in the room using life cycle assessment in projects, or that maybe you guys have concerns or certain challenges? The idea would be to have an open discussion on this, or oh, we've got, okay.
Hello, my name is Andrea Kurz from Bremertech in Austria. We are partner in the SNAG project, and we will do life cycle assessments and life cycle cost analysis. How do you, in your projects, handle the end-of-life considerations that you have in all these? Because it makes a big difference if you include probably in the housing considerations the end-of-life cost or not.
Okay, thank you for the question, and it's a very relevant one and also a tricky one, therefore. I think for now we are stuck to scenarios we get for each country, but yeah, there is a huge uncertainty on those scenarios, so I think there is room for improvement. But I'm afraid for now that's the best we have, because there's as we saw in the projects on circular economy, there is not too much known about
the end-of-life treatment and how we can change it in the future. So I think that's a huge research gap that we can still work on to get more data and more clarity on that.
Thanks a lot.
Yeah, I had a microphone, so I could just start talking maybe. I had a question for, I think it was Nirvana, with the combination of the three methodologies. I know it was a very new project, so perhaps you haven't considered everything yet, but what is the weighting between the different priorities? Because, I mean, depending on the project, depending what you're using it, maybe your priorities between social sustainability or environment, they could vary. Will it be possible to choose what you find more important, or how would you do that?
Yes, thank you for your question. So what you're mentioning basically is what is called materiality assessment. We call materiality assessment in social life cycle assessment. I think it really depends on the product you are analyzing. For our case study, we will analyze window frames, for example, and we are starting from job creation. We are not considering really, health, job creation, and fatal accidents. So you shouldn't really pick any aspect, of course, and in a correct social life cycle assessment, the way to go would be it depends if you want to analyze the foreground system or the background system. If you analyze the foreground system, the correct way would be to conduct surveys and to involve stakeholders. But for example, in the case of Kalin, he's considering social aspects that are quantifiable, that are somehow related to social aspects. Then you can include more. I don't know. How did you select those ones? Literature review or sorry? Did I answer your question?
Yeah, I think so. I just thought it was interesting, depending on what you want to achieve, depending on where and when and what product, of course. So it could be the environmental impact could be more important in some cases than others, for example, compared to. But yeah, I think you answered my question. Thank you.
So let's keep the ball rolling. Okay. Yeah.
Thank you. Hi, hello, everyone. My question is actually, this is Merve, by the way, from Istanbul, Turkey, and Demir Energy. I'm also experienced in doing life cycle assessment before, but more from the environmental aspects. And what took my interest during the presentations and all the session is that we are mainly focusing on from the environmental impact indicator perspective. We are mostly focusing on the global warming potential. But the reason that we would like to do the LCA is how the human interventions is affecting all the ecosystems, and the environmental mechanisms is not only part of the air pollution and how much CO2 or the greenhouse gas emissions we are emitting. We have also some other pollutants that would affect the water bodies, like the photochemical smoke potential and so on. But what took only my interest from the from the Leuven University, sorry if I'm saying wrong, I think this would make the value, and we should mostly focus on all the environmental mechanisms, because what we are trying to fix from somewhere might affect the other bodies and the other important or health impacts, let's say. I know this is a really huge concept that we should work on multidisciplinary, but this is a critical question to the room actually, since there are many experts on the LCA, and I think this session is more like a workshop. Anyone would like to answer it? They are open.
Yeah, I think indeed it's very important, and I think it's more what I want to say about, for example, the Miracle project as well. So they wanted us to come into the project and do an LCA, but they wanted us to focus on indeed only global warming potential. But then also they gave us compositions, and they were looking into everything, and they already looked up on the internet, like, okay, we think these materials have a lower CO2 emissions, so we will use this and this and this. And then they came with compositions, and then, for example, we saw that limestone, which had as an aggregate a quite low impact, but then they used explosives to mine this, and these parts of these explosives would go into the ecotoxicity for fresh water more. So we saw that by using this part went very high. So that's also when we stated, okay, guys, we also don't think this is a good option. And there was like friction between the two teams, because they were like, no, but we only want to look into this global warming potential, because that's what most people just ask. So we also had to, how do you say it, like persuade them and saying like, okay, we think it's important to look into everything. So I think it's also from very standard and high up, they also only ask you often to only do the global warming part. So I think indeed it's very important to also investigate all the others, because otherwise we would have a very high impact on other indicators which we didn't use before.
Thank you. And anyone who would like to add more of their opinions, I'm open to discuss later also.
Yeah, just maybe a small message of hope, because I think amongst LCA practitioners, it's not very strange to look at more indicators, and it's, practically it's not very hard, because the most time consuming is modeling your building. So it's mostly a question of selecting the method in your software. But I would like to say, from a policy level, we see that things are moving. So now, first we had the EPPD that was only focusing on energy. Now we have to, in the future version, we have to include the carbon emissions. But if we look at the levels framework, there is an option to do a full LCA. So I think it's a matter of time and a matter of us showing those additional results to make people aware that be careful, you lower CO2 emissions, but you create a problem elsewhere. So I think we can move forward in a good direction now. And maybe now I can...
Sorry, Claudio. Just to nuance that a bit, it's really good that we have all these indicators in the LCA, of course, but the drawback is that you will only focus on the indicators you can measure. An example is biodiversity, which is really hard to quantify, and that's something that's usually not accounted for in LCA. You can find proxies with land use, for example, but that's never going to be perfectly what you want. And so there's always this little risk of letting some aspect out of your scope because you're not measuring it. So it's really also difficult. It's great to have LCA because we have 17 indicators or more that we can actually put numbers on. But there's also a lot that we have to remember about, and that's the... Just to nuance a little bit the work, but we are able to find...
Yes, but it's some chemistry knowledge. I mean, there are some mechanisms that already, we know from the environmental balance perspective. For example, how much phosphorus you are emitting, then you have some effect to the water body. So I'm not saying that including all the 17 indicators, but there are some mechanisms that is already known how to calculate from the chemistry perspective, and of course you need to have some chemistry knowledge on that. Not so many indicators. Definitely. Thank you.
Yeah, hello everyone, Claudio Petucco from LIST, the Luxembourg Institute of Science and Technology, and I have one question for Els from your presentation. Sorry, it came with a little bit of delay and reflection about that. There were a couple of points I would like you to explain a little bit more. One is about energy prices. You mentioned it a little bit, and I was wondering how much your result on your axis in which you were placing different solutions, how much they would change those points, their placement in the 4 quadrants, how robust is your solution. And then the second point is that you were somehow putting together the social component in terms of the financial cost for the households for the installation, if I understood well. I don't know if it was a life cycle costing approach, yeah. And I was wondering if we could put together an economic analysis more in terms of return of investment, because maybe there are some solutions that are not accessible, but they could have a higher return on investment, and therefore the problem would be more letting people access to credit to finance those solutions that could have a higher environmental positive impact or lower negative impact. Yeah.
Okay, that's indeed, those are very relevant questions, because we had the past years some high fluctuations in energy prices. And it depends on what you're looking at. If you want to range or make a ranking of solutions, if your energy prices go up, it's the same for all the solutions. So they just all become more expensive, but the ranking doesn't really change a lot. So if like the best will be the best, the second will be the second on your list. So in that case, it doesn't really change a lot. Of course, if the prices between, the price gap between electricity and natural gas is bigger or smaller, that has a huge influence. So yeah, we did some sensitivity analysis on that, but as the market prices are, well, at the time when we did it, were very much fluctuating, it was like, yeah, it was very hard to do so. But now, I don't know in all the countries, but in Belgium things stabilized a bit again. So we can have some parameters, including the changes over time, to see how robust it is. But yeah, it's indeed, if you look at costs, and there are some very strange things going on the market, same with prices of the materials. We also had a huge increase of some materials, others didn't. So that's a very large uncertainty in that kind of assessment. And the second question was... yeah, the return of investment. That's something that's often requested by the owner, the building owner. And well, if you have all the data to do a life cycle costing assessment, it's also very easy to give the results for the return on investment. But we found that if you only look at the return on investment, then the solutions with a lower investment cost often, yeah, they have a faster return on investment, but often on the long run, they are more expensive. So that is why we would like to focus on both if we do a cost assessment, to make sure that you do not select it on a short time frame, some solution that might cause a problem on the long term. I think an economic assessment should include both. I don't know how your thoughts are, but you want to comment or?
No, I think I totally agree. But when the longer you go on your time frame, the higher the risk of price fluctuation uncertainty. So there is always this trade-off. But definitely, yeah.
Hello, this is Esra again. I have more of an existential comment or question, I don't know, whatever you call it, but it is also relevant to it, what Merve commented before. I will go back to social LCA because I have been working on it recently. And the thing is, there are not much studies or benchmarks to look at for the social LCA. Relatively for products or companies, that's more of a case. There are some case studies there. But if we look into it, the indicators that we are selecting, for example, are the ones that we know that we can find. It's not just things that we need to look at, but the ones that we So I'm like, okay, we are doing a life cycle assessment, but are we really assessing something? I'm not sure about that. And Nirvana, I have a question for you, and I love your name. It reminds of a cool rock band. You mentioned about job creation. Actually, you replied this question from before a little bit, but you are working on job creation for the social LCA analysis. Are you considering any other aspects of, for example, for the community? Are you going to look into the impact on the community or the tenants, or no, you are doing it for the PVCs, so
PVC.
So you're doing it for a product, but maybe the well-being of the workers, I don't know, there are those kind of there's methodologies for products, so maybe you might want to tell us about that. Thank you.
Thank you for your question. One thing, there is a framework, the guidelines for social life cycle assessment of products by the UNEP, and they have a whole framework with different impact categories. So you're familiar with this framework. Okay. Answering to the question, yes, we are going to consider job creation and also health, so exposure to different chemicals, and accidents and working conditions in construction. So we aim to cover all of those impact categories. Yes. And you were saying something about the data availability. Yes, in social life cycle assessment, it's a real problem because in the end, as you said, you end up using the data that is available. But it depends on the type of assessment you want to do. Because if you want to assess the foreground, and you do primary data collection, so you do surveys and interviews, then you can have some flexibility also with the indicators. Of course, it's complicated and it costs a lot and takes time, but I think also the quality of the assessment can be better.
I just wanted to, we've got about 5 minutes left. I just want to take the time to go back to the end of life question and maybe give some insights on what is happening in REGEN. So in one of the demo sites, the one in Milano with social housing, I think there's 2 blocks of social housing that are going to be demolished and they want to do a new project. And the way that we are approaching this, and it's not just in REGEN, also in LegoFit, I think we are doing a similar approach because we are involved in these 2 projects, with Demir Energy being the coordinator. We kind of need to introduce a stage of assessing what we want to do before we analyze the end of life and the LCA of the components. So what I mean by that is, and I don't know if GTB Lab, Elma from GTB Lab is here, but in REGEN she is involved in assessing the reusability potential of components using, this is their methodology, and so they look at different empirical indicators and they try to assess, okay, it makes sense to take out these windows and reuse them, and it doesn't make sense to reuse the concrete beams, so those go into whatever the local policy is for recycling. And so from this, you derive parallel scenarios of LCA. So then I guess LCA should come after this, because the first one gives you an indication of I should do this thing this way or the other way. And then for each of those 2 scenarios, for example, I would do an LCA assessment according to a more detailed study to give me a better idea of the pollutants, emissions, and so on, of this in case of the REGEN project and intervention. And for the LegoFit project, we don't have GTB Lab as a partner, so we are looking at the Ellen MacArthur Material MCI Circularity Index. I don't know if you've heard about that. It's a relatively simplified one, and we need EPD data of products. The problem is that these are old buildings, so there is no EPD, so we kind of have to use equivalents to get an estimate, but it doesn't give us real impacts, I think, by the end of the day. So it really is a big problem, I think. I don't know how that might impact in the long run. Okay, any other questions or coffee break? I think we're supposed to 3 minutes? Yeah. If not, yes, please come and see the presenters after. Ask them questions. Come see the REGEN booth. We have a nice interactive table you can play with and have fun, if not, for the next sessions. So thank you very much, everyone. Thank you for the presenters.